for the H2O, now H2O is bent in shape. Now H2O is water and it is combining. We know that, right? H2O is combining, so it will have bond pair and it will have lone pair. So now we don't know how many bond pair and how many lone pair to have. So now we have to find that out. How can we find that out? We have to get, oxygen is the central atom. Remember I said it in the voice note yesterday that it's the central atom that usually determine the lone pair and the bond pair. So we know that oxygen is what? Oxygen is number 8 in the periodic table, which we just did now, and adds an electronic configuration of 2, 6, right? Which is what? K, L. So this one to the K shell belongs to the L shell. Are you getting the point? So now we have what? Now let's write the K shell, which is, sorry, we have something like this: 1, 2. Sorry, that is too small. Then we come again. Now let's draw for this L. We have 1, 2, 3, 4. It's not yet complete. 5, 6. Now take note that is the outer one that is to determine the what? Lone pair. Take note, is the outer one that is to determine the lone pair. Nothing has to do with this two inside. As I said, that this one inside is just sitting down and looking. It's just looking at the way the outside are performing their magics. You get? This is combining. There's H2, hydrogen and oxygen. So it's not just oxygen. So now there will be bond pair and there will be lone pair in this one. So we have what? 1, 2, 1, 2. So we have 2 lone pairs. Now we have 2 lone pairs. Now remain your bond pair. Now we still have to do the bond pair. Now how many bond pair does this one have? Now this one that are here, these are your lone electrons. These two that did not combine, they are your what? They are your lone electrons. So now hydrogen is H2, right? H2. Hydrogen is H2, meaning that 2 molecules of what? Hydrogen, or 2 atoms of hydrogen. So that means hydrogen has 1 electron. We all know that, right? So hydrogen has 1 electron. So since hydrogen has 1 electron, let's take this as hydrogen. Let's take this as what? Hydrogen. Hydrogen will now bond with this lone electron, and hydrogen will also bond with this lone electron. Are you getting the point? Now they've bonded. Now these are your what? Bond pairs. Are you getting? Take note that hydrogen is constant. Hydrogen atom has what? 1 electron. So it will bond with this 1 lone electron that is there. To bond with this 1 lone electron that is there. It's H2. So 2 hydrogen. So you now have what? 2 bond pairs. Do you get? So remember I said that your total electron pair, TEP, is equal to what? Your bond pair plus your lone pair. So your bond pair is what? 2. So 2 plus 2 is 4. So in total we have 4 electrons in your H2O. So now you can see that there's a repulsion. You can see, we said the higher the lone pair, the greater the repulsion. We said that the higher the lone pair, the greater the repulsion. And I said that there's always what? This is the lone pair. I said that there's always repulsion between 2 lone pairs. They usually fight each other. Now they are repelling each other. So since they are repelling each other, this one will come here. It will repel this one. No, this is the bond pair. So bond and lone pair repel. Bond and lone pair will what? Repel. You can see they will repel. That's why it has a V shape. You can see it. They are repelling. They are repelling. They are repelling. They are repelling. So you can see that since these two are repelling, they will come here. They will repel. They will come here. They will repel. So, but it is greatest here. That's why you can see that your hydrogen has a what? Your H2O has a what? Has a V or bent. We call it V or bent shape. So it's not exactly V like that. So it is actually bent shape or V shape. Do you get the point? Now C for CH4. C for CH4 here. Very simple. Now CH4 one is simple. Do you get? So you have, remember your carbon is the central atom. It is the central atom that usually determine the lone pair. It is the central atom that usually determine the lone pair, which is your carbon. So you have what? CH4. So carbon is equal to what? Your lone and bond pair, sorry. Your carbon is equal to what? Carbon is equal to what? Hydrogen, helium, lithium, beryllium, boron, carbon. Carbon is 6, right? In periodic table. So it will be 2, 4. Are you getting the point? So we have KL. Can you see it? So now that it is 2, 4. Now let's draw it here. We have what? 1, 2. We now have another one outside. We have 1, 2, 3, 4. So you can see it here. Can you see it? Abi, carbon is 6 now. Hydrogen, helium, lithium, beryllium, boron, carbon. Carbon is 6. So it is what? 1, 2, 1, 2, 3, 4. So you can see here that it does not have any lone pair. It does not have any what? Lone pair, because it is not combining with anything. You get? It does not have lone pair. The only way it can have lone pair, if we join another one here, we join another one here, we join another one here, we join something here, it will have one lone pair. If we join another one here, it will have two lone pair. If we join another one here, it will have three lone pair. If we join another, it will have four lone pair. But now it does not even have any lone pair because it does not join. So CH4 has 0 lone pairs. But it has bond pair. How do we know it has bond pair? Remember CH4. So we have 4 electrons of hydrogen. So hydrogen is here. Hydrogen is here again. Hydrogen is here again. Hydrogen is here again. So they will bond. You can see they will bond. They will bond. They will bond. You can see. So CH4 has what? 4. 1, 2, 3, 4. Has 4 bond pairs. You can see it. It has 4 bond pair. That's why you can see that your methane is tetrahedral. It's something like this. Something like this. You can see it is what? Tetrahedral. So I'm sure you guys understand this now.